Okay, so this is the question that is count subsets with some k. Like this is very good question. In our previous video, we saw we have to return if there is any of the subset whose sum is equal to k. We simply return true or false. But in this case, I'm talking about this question there. So here it is. I'm saying about this question. Here it is saying if you are able to found this, you simply return true or false there. But like now in this question, we check whether how many of the subsets we are able to find, and we have to return the count there. So this is a little bit tricky than our previous question there. So one thing there, first of all, let's read this question carefully. We have given the array which is of size n and the target sum the k there, and we have to count the number of subset there. Now you can see the constraints here, like size there. There's an area of what are the elements possible in this question, and it is of, since size can be very large, so we can use the modulo. So the main thing that I want to share you, you can see in this array the number of elements are always positive integer. So first of all, one thing there, if the integers are negative, so you can say, you can like think about one thing. In our DP we simply store the elements till index I, and what are the remaining sum there. So if the array contains the negative elements also, so in that case we are not able to using the DP. So we should we don't go with our classical DP solution. In that case we have to store any of the other data structure, like we can use the hash map or map there. So in that case we don't go for this classical. So first of all, I want to clarify you that there contains only positive integers. Now there might be some cases also in in similar questions there, in which there the array may contain the duplicate elements. So since each of index is treated as a distinct, so we have to count each of the element as a distinct. So don't confuse that part. I already already explained, again explain in my later part there. uh, so I think first of all, let's say this array is given 114 comma 114 at 5, and k is equal to uh, okay, and there's a target value is equal to 5. So there's not given there. Okay, okay, so I think let's say we have to for this test case, if we are, the target value is a 5 there, so what are the valid test case, valid subset there? So either 1 comma 4 and this 1 comma 4. So see carefully, these are both distinct, even that the element of number of element and the elements appearing is the same. So this one and this one, since they are the duplicate elements, but they are treated as a distinct because they are at a different index. So don't confuse with this. And so this and this and this, so totally 3, so output will be 3. So this is very crucial test case. So both ones are treated as a different index, so they form different subset there. Now since the what the intuition in this problem, at every index we have two choices: either we have to do not pick the current element, or either we have to pick the current element only in the case it doesn't exceed our remaining target. Okay, so I suggest you should go for my previous video, in which I have to this doesn't ask for the count, it asks for whether it is available in this our array or not. But you should go afterward, you have to come to this video. Now here we must count the number of ways, and since here it is asking about the number of ways, so at every of the element we have the two choices there. And since if there are the multiple choices here, means we should go for thinking about the recursive solution there. So the recursion solution, and after it we make our recursive tree there, and after it we check whether we can optimize it or not there. Okay, so here I first of all, let's have to explain you. There's I write the our target there. Okay, in which I have to write the what it means there. It is nothing but the simpler number of what are the number of subset there. What are the number of subsets there? That is from, I can say, from index number 0 to I. So it is simply this thing such that their sum is equal to target, like here understable, so I'll not repeat this. And like what we are in this, we have to find in this question there. So we have to find this, okay, n minus 1 comma k. Okay, so we have to start from the ending and we have to reaching to the starting to our array and checking whether how many of the subset we are able to find, which form which can validate this condition, like their sum is become the target value. Okay, so uh, and like you see in my previous video also, we have we have the two cases, we have to take and we have to non take part. And if we have to take, our target also decreases. And like this is only considerable whenever this element doesn't exceed our target value. Okay, so now there's one crucial things also there. uh, uh, in some of the cases this is very confusing. We can say if our array contains 0 also. So like what's I can say I use the not word here. So what's different in these questions there? So whenever I have to discuss about the base case in this question there, so there might be three cases there. So what are these three cases there? So first of all, if our, let's say our target, we have to reach our target value become 0 there. Okay, I say target becomes 0 and our array is still, I can say the 08. I am not able to write it, I don't know why. Okay, so I mean this is again the 0 there. So target is 0 and the array is also 0 there. So there might be the two subset possible here. Okay, like what are the two subset possible here? So here we can return, what we can return here, 2. Like now why? Because the one empty array, like let's say we draw our recursive tree there, and let's say we are able to find, but like after finding the target 0, we reaching the state such that our target become the 0, doesn't mean we have to stop there. We have to go to further cases, we have to go down again down to the tree, such that there might be the possible cases that the some of the zeros are again the present in our array, so that we can encounter these as also, so they might increase our cases, some cases also. So for that case we don't have to stop there. So in which what are our case number 1 there? Let's have to have this. Okay, so what are the case 1? In case 1 we have to return 2, in which our target become the 0 and our starting also contains 0. So what are the cases there? Either we have to skip that or either we have to take that element. So in that case we have to take that element, either we have to return the 2. So now what the other case possible? In that case we can say our target it become the 0 there. Okay, so in that case we have to return 1. Why 1? Because we simply return we simply skip that part also, because we are not able to take that part. Now what our case 3rd there? Case 3rd is nothing. Let's say our target is not reaching 0, but we are reaching at the end case, like I'm calling these for our when we are reaching our index is equal to 0 case. For that case also, for that case only, why not able to write this? And let's say starting from this, if our index is equal to 0. Okay, So so what the case number 3, if array of 0 become our target value, so in that case also we simply return 1. Like now why 1 there, because that our subset become that number or only there. Okay, and what are the remaining cases? We can say again what case number 4 there, case number 4, in which all of the remaining cases in which we have to simply return 0. Okay, like this is for the this is very crucial part. Again I have to explain you in the by giving the example. Like first of all, take take the dry run. For this case, the you have given an array 1 2 3 there. We have to given the target value is 3, and we have to calculate what's the f of 2 comma 3. So there's the two cases, either we have to take or non take there. Okay, so like how to do this? So simply we can say one thing, like if we have to start from here, if we have to take, so our target becomes 0, and here our target doesn't changes. Okay, so 1 comma 3 1 comma 0. Now you see one thing there, like our target becomes 0, so it doesn't mean we have to stop there. We can go to further cases, either there might be the cases, or like we have to the 0 again 0 may be available in our array there. So like we have to go to further cases okay, again there. Okay, so you have to draw this in the and so on. This goes on till the downer, this trees goes on. So we see many of our cases like f of 0 comma 1 or f of 1 comma 0. These are the maybe the some of the cases that are repeated again. If we check for the maybe higher test case there, so these are nothing but the overlapping subproblem. So that means they suggest to use DP there. Okay, so like I simply coming to this part there. This is the coding part there. So this is the main function there, where this is size initialization, and this is the calling of the function. Now this definition, this is first of all, if our like I think yeah, okay, so you should go call for this like this is again the brute force code, since it gives the TLA, because there's a time complexity is exponential. So go for this memoized version there. Okay, so like use the DB vector here. Okay, so there's the base case. What is it? When we are standing at the ending of starting of our array, so there might be 3 cases possible. So in this case possible, like I already explained you here. So here I have to return 2 there, return 1 there, and in else condition we have to simply return 0 cases. And there's a 2 condition, skip, and there's a not skip means take part there. And since we are not guaranteed whether we are able to take or not, so since we are initialize it simply with the 0, because here we have to return the value of the count. So that's why simply add up the both the conditions. So that's why we take this as 0. In previous questions we take this as a false condition. So it depends whether it is a boolean or we have to count or not. Okay, so this is simply the time complexity and space complexity for this question there. And since there are the very huge test cases also, so in that cases to handle those cases we have to use the mode value here. Okay, and like let's say wait a second there. And okay, like to understand how's our base case working here, so let's take, I will to explain you with the example there. So coming to new side there. Okay, let's say we have our new array. Okay, that is array is 0 comma 1 comma 2 there. Okay, so this is our array, and what is our targeted value here? So it is nothing but the target value is the 2 here. Like now we have to find what are the count there, what are the possible number of count here possible here. Okay, so we have to simply write what are the possible test subset here. First of all, it is empty there. So first of all I have to write that, after it I have to explain. 0 comma 1 comma 2 there. Okay, so there's a 3 3 6. Okay, like now this is as I understand it. Okay, so this is first of all the subset empty, so what it sum is as a 0. This is also sum as 0, sum as 1, there's some 2, there's some 1, there's some 2, there's some 3, and there's some 3. Okay, now how many of the subset giving the sum as a 2 there? So one of the arrays, one of the subset is this, and one of the subset this. These are the two subset which are giving the sum as 2. So what are the so what we written simply the 2 there. Okay, like now why the 0 changes our count there? Like in our previous video we doesn't bother about the whether 0 is possible or not, because in that case in that question the 0 is not there. But like how is our question changes, or why 0 is very playing very crucial role in these questions there. So see, if an element is, let's say we are standing at an element at an index there, and like our current element is our 0, so we have the two cases, either we take that 0 or either we have skipped that 0. So in both of the cases, like I have to let's say if an element is 0, so we have choices. Like what are the choices? Either take or either skip the 0 and the skip 0. So we can say one thing there, in both of the cases both keep our sum as unchanged. So like in both of the cases, if we are standing at the 0, our sum is unchanged in both of the cases. So we can say one thing, so every valid subset here can be duplicated by including or excluding 0. So like there, since in the case whenever 0 is available in our array, our number of the count of the subset is increasing comparison to previous cases whenever 0 is not present here. Means all our valid is a subset become extra valid subset are also found in cases when 0 is there. So every valid subset can be duplicated by including or excluding 0. Okay, now let's say take another, you can take another example also there in cases I think okay, so let's say okay, let's say I have to explain say this is our arrays, simply our 0 comma 0 comma 0. Okay, so this is our array, and what is k? Simply 0. So what are the subset here? The subset or 0 there, or 0 there, or 0 comma 0, or 0 comma 0 here, or 0 comma 0 here, or 0 comma 0 comma 0. So how many of these? These are nothing but 3 and 3 6 8. So 2 power 3 means 8. So these are nothing but 8 subsets are there. Okay, now we see one thing there, we can say our every 0 doubles number of subsets. Okay, so like up now we see why our base case handles this. So in DP we uses if our target is equal to 0 and array is 0 is equal to 0, we have to return simply true there. Like now see why. So since because at index number 0 we can take 0 or either skip 0. Okay, so since both produce some 0, so that's why I use this case. So like now you can understand why I using this case. So in that case we simply return 2, because we can either skip that part or we have to take that part also. Okay, so so finally I can say one thing, if we have to check in our questions, if does the like you can ask to yourself, does the array contain 0? Like I have to, does the array contains, wait a second, 0. So if it contains, so yes, if it, so subsets count, you can say multiplies. So that's why we should carefully see for those questions there. So for that case we have to make this base case there. And like you can say one, like at the starting of the video I already told you about, we have to check whether they contains only positive numbers or negative numbers. If that contains negative number, so we can use any of the extra good storing, let's say we can use the map here also. Okay, so that is our question there.